What's up guys, welcome to our channel Science Power Vlogs. So today we're going to talk about the history of atom. So let's get to it. So first off, we're going to talk about John Dalton's in 1808. Experiment led to his discoveries. Elements are made up of identical atoms which cannot be created or destroyed. They can combine to form compound in whole number ratios. Chemical reaction involves the breaking or creating of bonds but never changing elements into new elements. Dalton atomic theory. Elements are composed of extremely small particles called atoms. All atoms of a given element are identical, having the same size, mass, and chemical properties. The atoms of one element are different from the atoms of other elements. Compounds are composed of atoms of more than one element. In any compound, the ratios of the numbers of atoms of any two of the elements present is either an integer or a simple fraction. A chemical reaction involves only the separation, combination, or rearrangement of atoms. It does not result in the creation of destruction. Dalton's law of partial pressure. At constant volume and temperature, the total pressure of mixture of gases is the sum of partial pressure of all the gases present. This is the formula of Dalton's law of partial pressure.
We're going to talk about Joseph John Thomson. J.G. Thomson attended Trinity College at Cambridge, where he would come to the head Cavendish Laboratory. His research in cathode rays led to the discovery of the electron, and he pursued further innovations in atomic structure exploration. Thomson won the 1906 Nobel Prize in Physics, among many accolades. Early life and education of Joseph John Thomson, who was always called J.J., was born in Chitham Hill, England, near Manchester in 1856. When his father was a bookseller who planned for Thomson to be an engineer, when an apprenticeship at an engineering firm couldn't be found, Thomson was sent to bide his time at Owens College at the age of 14. In 1876, he received a small scholarship to attend Trinity College at Cambridge to study mathematics. Thomson worked in the Cavendish Laboratory after graduation. Under the tutelage of Lord Rayleigh, he quickly earned a membership in the prestigious Royal Society and was appointed Rayleigh's successor as the Cavendish Professor of Physics at the age of 28. He was both respected and well-liked, and students came from around the world to study with him. His research. In 1894, Thomson began studying cathode rays, which are glowing beams of light that follow an electrical discharge in high vacuum tube. It was popular research topic among physicists at the time because the nature of cathode rays was unclear.
Rutherford overturned Thomson's model in 1911 with his well-known gold foil experiment, in which he demonstrated that the atom has a tiny and heavy nucleus. Rutherford designed an experiment to use the alpha particles emitted by a radioactive element as probes to the unseen world of atomic structure.
In 1913, Niels Bohr proposed a theory for the hydrogen atom based on quantum theory that energy is transferred only in certain well-defined quantities. Electrons should move around the nucleus but only in prescribed orbits. When jumping from one orbit to another with lower energy, a light quantum is emitted. Bohr 1913, or also known as the Bohr's model, is the basis for our modern atomic model. In this model, Bohr added the electron shells, which circles that are surrounding the atoms that soon will be changed to neutrons by Chadwick.
Hi guys, we'll talk about the theory of atom written by Schrödinger in 1926. In 1926, Erwin Schrödinger, an Australian physicist, took the Bohr atom model one step further. Schrödinger used mathematical equation to describe the likelihood of finding an electron in a certain position. This atomic model is known as the quantum mechanical model of the atom. Unlike the Bohr model, the quantum mechanical model does not define the exact path of an electron, but rather predicts the odds of the location of the electron. This model can be portrayed as a nucleus surrounded by an electron cloud. Where the cloud is most dense, the probability of finding the electron is greatest, and conversely, the electron is less likely to be a less dense area of the cloud. Thus, this model introduced the concept of sub-energy levels.
What was Chadwick's atomic theory? James Chadwick played a vital role in the atomic theory as he discovered the neutron in atoms. Neutrons are located in the center of an atom in the nucleus along with the protons. They have neither a positive nor negative charge, but contribute the atomic weight with the same effect as a proton. In 1932, James Chadwick bombarded beryllium atoms with alpha particles. An unknown radiation was produced. Chadwick interpreted this radiation as being composed of particles with a neutral electron charge and the approximate mass of a proton. This particle became known as the neutron. What was Chadwick's theory? In 1932, James Chadwick proved that it consisted of a neutral particle with about the same mass as a proton. Ernest Rutherford had earlier proposed that such a particle might exist in atomic nuclei. Its existence now proven, it was called a neutron.